Thank you, everybody, for being here. Glad to see some, finally, getting some in-person conferences. I've definitely missed that. My name is Moshe Zadka. My website is cobordism.com, where you can find every way of contacting me known to humankind. And today I want to talk to you about building containers for Python applications. Actually building good containers for Python application, because bad containers are pretty easy to build, but that's not very interesting. And I want to start with acknowledgement of country. I live in Belmont, which is in the San Francisco Bay Area Peninsula, the ancestral homeland of the Ramaytush or Holoni people. So, before we talk about how to build good containers, we need to talk about what is good. And I'm sure we all know what is good: to crush your enemies, to see them driven before you. I'm sorry, that's like the other talk I'm doing. Okay, cool. Sorry, back to this side. Okay, so what is a good container, right? We want to be fast, right? Faster is, in general, all other things being the same, better. We want to be small, right? Regardless of how you're going to store your container images, right? There's like a lot of ways. Eventually, you have to pay for the storage. Doesn't matter how many layers of abstraction. Eventually, you're paying for the storage one way or another. Less paying is good. You want to be secure, right? Like nothing more embarrassing than someone using the fact that you had like a old security hole lying around in your container to get into your environment. Definitely not a conversation you want to have. And you want to be usable, right? Like people need to be able to kind of, get that image, do whatever they need from that and deploy it, right? So that's, like basically our basic metrics. So, but those were like super high levels. So what do we really want, right? Like, so all of these things, right, are supposed to accomplish the high-level goals, right? So first of all, we want to make it easy to keep up to date, right? That's the most operationalized way to say secure, right? You can't build something that doesn't have security issues because there's going to be. What you can do is make sure that at least any security issue that has been fixed is fixed in your container. You want to make sure that you build reproducible builds, right? If you have a small bug fix, you'd want to make sure that, you don't change other unrelated things because that's going to be fun to test and deploy, and that's going to be slower to deploy, especially with a hot fix or a security issue. This looks super specific, right? No compiled in prod. Unfortunately, if you follow tons of the instructions that you find on random websites, about how to build containers for Python, you'll end up with compiled in prod. Sometimes because sometimes because the instructions are bad, sometimes because the instructions are not specific enough, and a little bit of misinterpretation, and awesome. So, and again, you want to keep size reasonably small. I say reasonably because it's really easy to go down the rabbit hole of trying to slim down here and slim down there, and at some point it's going to not be useful, and we'll talk, kind of in more details about that. But these are kind of the operational requirements. We got the high level, what are our metrics? This is how we're going to achieve those metrics, right? So that's good. So for me, the most important thing in up-to-date is install security updates, right? Because we're all going to build containers from something that has stuff. That stuff will have security issues because that's the world we live in. Hopefully you get it from someone who's responsible enough to give you security updates. You need to make sure that you consume them. But the question is when, right? And this is not an easy question to answer, and you probably are going to have complicated answers to that. If it's a critical hole, you need to have 5 days of SLA, except if there's already a problem in the wild where you have a 0-day policy. You're going to have a complicated set of requirements that in most realistic scenarios, you're not going to be in charge of, right? That might be part of your security team SLA or some contracts that you signed with some critical customers. Once you have that constraints on when, your job is to operationalize it. And so the exact answer depends, but what you want to make sure is that you control the when. If you control it, you'll be able to respond to the requirements. If you consume it randomly every time you rebuild, or you consume it never and you have to do something very complicated to rebuild, you're not in control anymore. Now when someone tells you, this is how you do, well, now you have to build that policy. So build those abilities before you start so you can adapt, because those policies will change as your company matures, as new customers are brought in or whatever, right? You suddenly have to work with the government and everything changes. The next thing you want is reproducible builds. The abstract definition of a reproducible build is that if you start from the same code, you get the same results. But there's a lot of ways to kind of interpret what same results means. If you interpret it in the strictest way possible, meaning if I get literally bit for bit equal code, I get bit for bit compatible output, you can achieve that. But it is really, really, really hard to achieve that. And it's not obviously worth it, so like in a lot of things, the best way to solve this problem is to redefine it. And kind of like reducing the requirements to like, it's more or less compatible, means that like, you don't have to care about, abstracting the build from the time, because then the timestamp in some file will be different. Sure, it might be that there's like a process in your thing that checks the timestamp of random files, but like just don't do that, and then you won't have to care about it, and that will be much, much easier. So that kind of reduction in like your goal, right? Like what is a reproducible build, will give you 95% of the value of a reproducible build. The problem with compilers in prod, the way I think of it, it's obviously you don't want it. Like nobody like start out with the requirements, I'm gonna have GCC in my runtime container that like every user accesses. Nobody has that. The problem is that it takes active work to avoid that, and if you don't put that active work in like several different steps, you're gonna end up with a compiler in prod, and that's gonna have a lot of regrettable consequences. It's surprisingly easy, right? Because what most Linux systems like doing is support your dependencies, right? You install something, it recursively closes, right? You pip install something that needs a C stuff, right? Like it will kind of try to figure out how to grab the compiler, right? There's like so many ways of things kind of silently and without your knowledge, grabbing something that grabs something that depends on something that, oh, okay, now you have a compiler, okay, great. With size, the problem is that you get into diminishing returns, right? Like going down from like, say, depending on specific distribution, specific choices you're making, going from 1 gigabyte to 300 megabytes, easy. Going from 300 megabytes to like 200-ish, not that hard. Scraping that down to 150, sure, you can spend 2 hours and kind of scrape down those 50 megabytes. Going down from this on that, you spend another like, kind of 2 days kind of figuring out, and you lose another 5 megabytes. You decide when to stop, right? How much value your time has versus how much time every byte costs in the output versus how many versions you build. But usually around the 200, 300 megabytes mark is when typically if you get paid halfway reasonable engineering salaries is when it's like, that's good enough. You do want to be aware of like somewhat like how much cost saving are you making, right? Are you actually paying for like bytes, or do you have like, kind of 10x the capacity right now that you anyway kind of like is going unused, and if you use it, that's fine, like don't bother. So it's a very local decision, how much effort is worth putting into that, but usually most realistic scenarios, around the 200, 300 megabytes mark, you're gonna be like, okay, that's done. Another parameter that's really important, it's gonna be really important for how fast the builds work, is that you support binary builds. Binary wheels. Binary wheels, supporting them well will give you two things. First of all, when you install and build them, it's gonna make a lot of like how you build the container, especially if you're doing multi-stage, and we'll talk about that later, a lot easier to operationalize. And it's gonna be a lot faster if you manage to find binary wheels that have already been built, either by the open source community, or if you have all kinds of requirements, or those binary wheels have not been built by the open source community, you can build them yourself, shove them into a local package index, and again, increase the speed of your build. So you want really good support for binary wheels, and we'll get to like why that matters in a while. If you have really amazing support for binary wheels, you get to simplify your image and simplify your build process a lot. This is a general thing. It doesn't have anything to do with Python, but this is super important. You don't want the user that the container runs, the main process that is starting up, being root. There are exceptions. Assume you're not one of them. You do not want that to be root. Any general hygiene, right? Like, less root stuff is like, good. But specifically in containers, this is super important. This is super important because if you root inside the container and you have managed to get access to the container, it's going to be much easier for you to perform a container escape, meaning get out of the container and start attacking the rest of the environment. If you're not root, usually most container escape attacks involve getting root. You're making the attacker work a lot harder, potentially getting frustrated, worst case, at least doing a lot more, which means that you have a few more chances for your auditing layer to detect that something bad is going on and start mitigating. So you basically want to make sure that you don't use a root. This is kind of a prerequisite, like assuming you don't run a root because you already figured out that that's a bad idea. You also want the user that you do run as to have minimal privileges. And the most important privileges to take away from that user that they don't need, shouldn't have, and it's really great if you don't give them, is permissions to pip install. Wherever your Python environment is, should be read-only to the user. That means, again, if an attacker gets in, they can just pip install stuff. Losing that ability, again, makes a lot of potential attacks much harder, means they have to work much harder, again, either frustrating them or at least pinging your auditing environment a little bit more, giving your security team a chance to catch them in the act. Fast rebuilds are really important. You notice I don't say fast builds, because fast builds are not important. Usually, where speed comes in is when someone is trying to do the edit debug loop. That's what you want to optimize for. Optimizing the first build, not so important. Optimizing rebuilds is really important because that measures how well your build process is responsive. The faster you do that, the less people will try to work around it. Now, you're not going to get perfect. It's still going to be not super fast. But the faster it is, the faster people need to run things locally or start editing files directly on a container, do all kinds of stuff that sometimes is essential to increase your edit debug loop, but the less people do that, the less than they have, oh, well, but that only worked in my local environment for that reason. Now I have to try it in the container, and now I have to rebuild. So the less times people have to kind of drop out of the main loop to improvise an ad hoc edit debug loop to kind of improve responsiveness, the more people will be happy. So again, not being perfect, you have to kind of take it as a granted, but this is kind of a linear, right? The faster you build it, the better off people are. Now, the first thing you need to consider when you're building a container is the first line in the container, which, with some minor exceptions, like comments and the like, is from. And after you type the letters F-R-O-M space, you need to put something after that, right? And that's your first decision. What do you do? And basically, what you're going to do is put in the name of a distribution. So you're going to have to choose a distribution. Now, I've been around for a while. I've been around in the 90s. I remember somewhat fondly and somewhat not fondly the distro wars, where people would go on /dot. It's a thing we old people used to have, and would yell a lot at other people for whatever distribution they have. When I said fondly, I mostly meant not so fondly, and I don't want to get into that, but I do want to give you some guidelines about how to choose about the distribution and how to think about that. So let's start with the base, the size. And the easy thing to say about the size, not an issue. Most distribution, if you use every distribution calls it something differently, server size or minimal, or each distribution have a different name, but they usually have a version whose proper name should be the container version, right? Because that's a version that's right for containers. It doesn't include extra stuff, because if you need extra stuff, you can, DNF or apt-get or whatever, install it later. But it does include, the basic stuff that reads, and you want it to be minimal. Now, most distributions have it. Like I said, it's kind of annoying to go through the documentation and figure that out, how they call it. Some call it server, which is why I like to call it server. But if you're making a choice and you don't have any other constraints, I found that Debian is easiest to go smallest out of the valid options. We'll talk about why some options that you might be all thinking about are not great. Because like I said, this is not to say that they're not great for other reasons. We are specifically talking about containers for Python, right? Maybe they're great for other stuff, not for our use case. The next thing you want is to figure out your kind of long-term support version, right? And the reason is because you have some process right inside to figure out when you jump from one version to the other. You need to figure out when to do that. That jump usually includes upgrading a lot of stuff that might potentially break a lot of stuff. That's fine. That's part of life. That's why we have a job. But that like we also have other stuff to do at our jobs. And maybe now is not the right time. Maybe it's a crunch time. Maybe like, you promised like a version and it's on your OKR and you need to finish things by the end of the quarter. It gets dragged out to the next quarter. So 2 quarters, you really don't want to think about upgrading your best OS because you have to deliver a feature and nobody will even talk to you about that. You want to make sure that when that time comes, you're not like, but we are going to lose security support in 2 months. We have to do it now, right? That's not a good place to be in. So usually, most things have 5 years, and like, they have kind of 2 years release practice, which means you have 3 years. Now, if you're slumped for 3 years, I don't know what to tell you. Like, figure it out. You have 3 years to figure it out. But it's perfectly okay to be slumped for like 6 months, 5 months, like even a year, right? That happens, like, business is business. But 3 years, I feel like, it's usually enough time that you can find some slot in those 3 years to do kind of the effort. So you want to look for something that has 5 years. Again, most distributions that you'll get usually give you at least 5 years. Some will give you more, that's okay. But that gives you the time to upgrade. The other thing you want to care about the volatility, right? So the reason you call it LTS or supported is because at the very least you'll get bug fixes, you'll get security fixes, right? When you do like, whatever is your distro's version to like, get upgrade, DNF upgrade, whatever it is, then it will grab stuff. Now, you want the security updates, ideally backported security updates, so you don't upgrade any major versions, because again, like that's not what you want. But what else does it give you? And this is a trade-off. Maybe you want some bug fixes, but you definitely don't want a lot of changes. If you want a lot of changes, you would just jump to the next version. So you want to understand the policy that whatever distribution you're using has. You want to make sure you understand it, and then you want to make sure that it's compatible with your desires, right? Like, I can tell you what you want, but I can tell you that it's really worthwhile to like look into that and think about it before you get the fix that you did not plan to fix, upgrade something that you do not want to upgrade, that broke all your stuff. Much better to think about it in advance. So I'll give a couple of examples, right? Debian gives you a long-term support version of 5 years if you take like all the different steps that like takes like a few kind of hours to kind of figure out the details on the Debian, but that's like the bottom line. You get LTS, at least security support level after 5 years. Debian tends to be extremely conservative in what it allows. Critical fixes, security fixes, everything backported, no major version update, that's it, nothing else. Again, if that's what you want, that's good because you get that. Another example that a lot of people use, so I want to cover that. Ubuntu also gives you an LTS of 5 years. Except it's weird, and you have to understand what packages you get from the universe and the multiverse, and like I don't want to summarize that stuff, but like I said, you need to read and make sure that you understand what you're getting and why you want it. It's fairly conservative, not quite as conservative as Debian, but so it will include some more bug fixes than Debian does, but it'll still not like do, most of the stuff will be backported. Alpine is a bad choice. Not in general, like there's a good reason for Alpine. Alpine solves the problem it's set out to solve really well. But Alpine uses muscle, not libc. Usually it doesn't matter too much, right? Like, that's also a fine C library. Very few people use like the 3 features in GNU libc that only GNU libc has and not other libc because it would be weird and why would you do that? But the other kind of hidden feature in GNU libc, which is like not really easily spelled out, is GNU libc hasn't upgraded a major version since the last century. And it has perfect backwards compatibility inside of minor versions, which means if you built something on some version of glibc, like glibc 2 point something, it will run perfectly on any glibc that's 2 point a higher number. That feature of GNU libc is used in like what Python binary wheels call many Linux, which basically will build a version like a wheel on a really, really old version of something, usually some variant on Debian or CentOS, something that gets supported for a long time. And then you can use that wheel no matter which version you're running because you're probably running a newer version. This is really nice because you can take that wheel, put it in, again, if it's from the open source community, it's like built by the originators. That's already in PyPI. Even if not, you can build it locally. Push it into your local packaging index, which you probably have, and if you don't set up DevPI, it takes about 5 minutes. And you get basically to not have to build it every container build because it's the same version and like people do the right thing. All that stuff, straight out the window if you use Alpine. Nothing of that pipeline supports muscle, which means if you use Alpine, you're going to have slow, annoying builds. Not because Alpine is bad, because it's different than what Python binary will support. You probably don't want a distribution that has probably rolling releases, because you'll get new stuff when you're trying to just get security updates. If you have an SLA for security updates, now the SLA is compounded by, but we also have to test it, like, these other three things, the upgrade doesn't break us. That's a lot less fun. You don't want it in your, again, if you have a desktop with Linux, I have a desktop with Linux, rolling releases are great, not for that use case. Because the updates can change major versions. Major versions are not backwards compatible. That's almost the definition of a major version. CentOS, since version 8, is a rolling release. So everything I said, it's not completely a rolling release, but close enough to a rolling release in that if you start to use 8, you'll get major updates, and everything I said applies. So just a reminder, kind of, if you think about which distribution is right. So your next line, after you choose a form, right, and kind of everything I covered so far is your first line of your Docker container. So I better move fast because you have a lot more lines in your Docker container. How much time do I have? OK, I'm good. So is how to get the Python, right? Like, fine, you have a distribution. You chose a minimal version, which means you don't have Python on it. So you're going to have Python on it. OK, well, you have a lot of options. But let's first talk about the one option you shouldn't use, which is apt-get DNF or whatever it is you use, install Python, not good. Distros use Python, the distro Python, for the distro packages. Unless you're building distro packages for your Python application, you do not want to use that Python. That Python is not designed for you. It looks tempting. If you use it, you're going to have a bad time. It's not designed for your user program. So, sometimes it doesn't even include pip or venv. Sometimes, they don't upgrade the patch version because they only patch security or critical updates. But if you have an application using Python that runs into a problem that Python fixed in a patch version, you probably do want that fix because your application is based on Python, right? So, and you're writing custom applications, right? So, System Python is going to have a bad time. You can choose a repo that's designed as a repo for Python versions for your OS build mechanisms. The most famous example is Dead Snakes for Ubuntu. So you add the Dead Snakes PPA is like something package, something, I don't remember what it stands for, but the idea is that you can add it as an extra source to your Ubuntu. Those Python, the ones in Dead Snakes, are designed for a user program. They do include stuff like pip and venv that you probably want. Another option is to get PyEnv on your thing. PyEnv knows how to build and install Python. It knows how to manage Python versions. It does a reasonable job. However, it does leave behind what PyEnv calls the shims, which is this weird layer of indirection for your Python versions. Not necessarily bad, but if you don't want it, you can use Python build. Python build is what PyEnv uses under the cover. So it's perfectly fine. It's equally usable as PyEnv. You do have to kind of, tell it a bit more what to do, exactly where to install it, but that's sometimes actually what you want. It builds and installs Python. But at the end of the day, it doesn't do a lot more than just, that, right? So, again, there are good reasons to get a Python build. It will abstract you how to get the sources, how to validate them against the checksum, but, there's not a problem with doing it yourself, or you can grab the tarball and put it in the repository. There's a bunch of options here. And then one configure, make install. That works equally well. I didn't specify the options for configure because you will have to think for more than 10 seconds about the options, but you'll figure out the options and you run it and you'll have a working version of Python. If you do that and you chose Debian in the earlier kind of choice options, then I have a cheat code for you. This. So Python images on Docker Hub are basically, they start with Debian and then they install Python more or less like that. I kind of simplified a bit, but that's basically what they do. No, if you were going to do that anyway, you can outsource that part of your job. You want to use a slim version, but we'll talk about it later. But you want to be very, very careful about what you're doing. But basically, you can get that for free. And again, that's a valid option if you already. I think the right way to model it is first make your choices. If those ended up being your choices, use a cheat code. Don't start by using the cheat code. Start by like thinking what you need. If you have decided this is okay for you, you can basically take the shortcut. Every single one of those options has like a three-way trade-off. How much control you have about how you build your Python, your build options, like your optimization options, CPU, stuff like that. How much work does it take? All our time is valuable. You probably can be doing something else. And how many problems you can run into. It's a kind of three-level trade-off. You're going to choose one point on it, and we'll have to live with the consequences. There's no way to avoid it. Whatever you do, you're going to have to live with the trade-off. At least now you know what you have to do. Assuming you're building it as a base for other things, you want to support multiple versions so people can have an upgrade path, right? Again, usually in modern environments, there's microservices. You don't want to have to force all the microservices to move at once, so you want to build a new version, allow microservices to move one by one. Even if there's one service, you probably want them to move on a PR to that branch, be able to test as much as they did. So you want to support multiple Python versions. Now, as you can know from basic math and the word multiple, 2 is the minimal, 1 is not multiple. More interesting is the higher level, you usually don't need more than 3. 3 is reasonable because Python now releases a minor version every year. So if you only support 2, that might be a bit of a tight timeline again for teams that are stuck in really bad circumstances, right? Again, 6 months of crunch time when two engineers left the team and also they have a super critical feature that's strategic or whatever. So giving the little bit of breathing space of 3 sometimes is reasonable. But maybe you're not in that position, maybe that's not likely to happen. 2 is also a good number. Almost no other numbers make sense. Like I said, I already explained why 1 doesn't make sense. 4, they don't need that, right? Probably if they can't figure out in the span of 2 years how to upgrade the version, the problem is not the crunch time that the 2 engineers leaving, the problem is that they can't allocate work appropriately. Now, I'm going to talk a lot about how to use multistage to make things better. Multistage is, I guess, a new enough feature that I do want to give a quick recap of that. So when you have a Docker multistage, remember that only one stage will actually be part of the resulting output. Well, so why do we have the other stages? Why is it, are they just there for fun? Well, no, they're not just there for fun. The other stages will help producing the final output stage. And there's 2 ways to use previous stages in the stage that actually does the output. One is form. A stage can start with a previous stage. That's really helpful when you want to use when you want to use stages as modules, because you can have shared code in some base module and the other stages move from that. But honestly, if that was the only feature you got, some creative text munging on Dockerfile would have given you the same ability. Not a great option, but that's not the main benefit of multi-stage. Just once you have staging, you might as well do that. The real advantage is copy minus from. So a stage can copy minus from a previous stage, which means one stage can prep files. It can install whatever it wants because it's not going to be in the output, and then you copy things from the previous stage to this stage. That is a really useful feature, and we'll talk about how you can use that when you're building Python applications. So this is not necessarily I wouldn't recommend using that as a good template, but this explains how you use stages as a module. So here is how I build both 3.8 and 3.9. Again, I really want to be clear that this is not how to build good containers. This just shows in a thing that fits on one slide how to use stages as a module. So, usually the first stage will be slightly more complicated, and the other stages will be more complicated, but this fits on one slide. But the main benefit is you can separate the build and the runtime. Now, especially if you're building stuff from source. Doesn't matter if it's Python or if you're building some native extensions from source, you're building stuff from source, and the common thing that you need to build when you're building native extensions or Python is compilers. Just like Chekhov's gun, we talked earlier about how compilers in prod are kind of the weird monster that lies in the shadows ready to pounce. This is usually how it pounces. You try building from source, you install the compiler, and that's it, right? The whole movie ends. So then this is usually, so this is how to avoid the monster, right? Again, I simplified a bit to make it fit onto the slide, but you basically install, start with a builder version. You need to install build dependencies. I don't want to get into these details because there's like a whole discussion I could do about that unfortunately I don't have time for that, but you can always like, catch up with me later if you want to talk about it. And then you build Python, say, to /opt/myorg/python. And then in the next stage, you do from Ubuntu as runtime, and then you copy the Python from the builder. That will give you what you want, right? Now you have something that has Python, does not have all the build dependencies that you installed in the first 2 stages, right? And that's basically the template for all variants, right? Regardless if it's Python you're building or like the extensions you're building, that's kind of gonna be the basic structure, the basic skeleton that you're gonna fit your stuff into. And you'll also notice that I kind of like try to optimize the layers, especially in the runtime. Again, we want Docker kind of startup time to be fast. The reason you want that is because that basically measures your elasticity. If you add another thing in your node, whatever kind of orchestration mechanism you use, Kubernetes, Swarm, manual, whatever you do, the first step is like downloading the layers and extracting them. Less layers means that it's less complicated and faster to start up, and that measures your elasticity, which means how fast you respond to like sudden increases in pressures, or how much extra capacity you need to build so that like when you respond to extra capacities in pressure, you have time to respond. So either way, this will make things better for everybody. And basically the way to kind of do that is to make sure that you put everything under one big directory, which is op.myorg, and then copy one layer. So basically you have the base layer, you have the, and you have kind of the layer that has everything that's special for you. When you build Python, and this is why it's important to do it in multi-stage, you couldn't do it without multi-stage, but you are going to be torturing yourself, at least like since I think like 2 or 3 months ago. Now Docker files can have here documents, so you don't need to put backslashes. That is a very, very small comfort to like, okay, that stage takes like 2 screenfuls. So like, that stage means like those 2 screenfuls are not cached, right? You can't cache in the middle of that. So that kind of sucks because if anything changes, like the rebuild is no longer fast. And plus it's like less readable, less understandable and things like that. Much better to do it in multi-stages. Who cares if you have a few extra layers on the build stuff? That's not going to be your bottleneck usually, even in most realistic CI environments. So after you build Python, now that you are kind of doing it in the build stage rather than the runtime stage, you have kind of like, a nice place in your Docker file to kind of, remove the tests, remove the, obviously don't have the build dependencies in runtime, and there's like other stuff that you probably want to remove. I don't want to get into these details. You can see a bunch of like, kind of skeletons. You can, for example, look at the Docker file of the official Python image to get a good sense. But tests and the static library are usually the 2 things that are like, the most space consuming and the least useful in your runtime images. Okay, so you've done that. Next step is to like install your Python level dependencies, right? Until now, all we have installed is like operating system dependencies and Python itself. Great, that's awesome, but probably at least like 30 to 90% of the reason you use Python is because of how awesome PyPI is. Great, which means you need to install dependencies. And probably at some level of the recursive dependencies, even if you think, I only have like 5 dependencies, how bad can it be? Well, when you recursively close it, pretty bad, right? Like not bad in bad, right? Like, it's not going to be worse for you, but it's going to be pretty long. And it's almost certain, right, by kind of like, basic reliability, at some point, some recursive level dependencies will need native code, because that's kind of part of what makes Python awesome, right? It's really easy to write native extensions, which it interface with like, the Postgres client and the MySQL client and like, optimized Fortran stuff and all kind of stuff. So, so you want to build the binary wheels within the builder image if they don't already exist in your PyPI or in the open source PyPI. And then the next step, you can basically, you kind of have another choice. You can copy the wheels, the binary wheels themselves to runtime and install them in your virtual environment. Or what I like to do is you build them with a builder, you install them in a virtual environment in the builder, and you copy over the virtual environment. Again, less useless stuff hanging around the runtime image, although you can kind of work around that. But it's kind of like, really nice because you can test it in the build time image, which is like the main benefit of that. if you're building a good builder image, you want to get patch shelves. The reason you want to get patch shelves is patch shelves will be what allows your binary wheels to be portable binary wheels, which means you can upload them to your local packaging index, which means you can make your builds a lot faster. So patch shelf is super cool. However, almost all distributions have a slightly older version of patch shelf. That version of patch shelf has some critical bugs that will produce broken wheels. Do not use that version of patch shelf. If you are going to use patch shelf, sorry about that. You're going to have to grab it and install it from source. Now, that's not a big deal because, again, only in the build stage. If you have some stuff flying around the builder image, it's not going to harm anything. So, yeah, it's OK. But patch shelf is what you need to install, not what you need to use. That's a big distinction because you're not going to use patch shelf directly. You're going to use patch shelf with a Python abstraction for patch shelf, and you're not even going to use that. You're going to use audit wheel, which uses a Python abstraction for patch shelf to use patch shelf. So from your perspective, as a builder, after you make sure that patch shelf is the right version, what you need to do is install audit wheel. But that's easy, right? So that's why I didn't cover that because hopefully pip installing is something that you're doing all the time. So you pip install audit wheel into some random virtual environment, or hell, you can even put it directly in the main environment of the builder because it's a builder. If the main environment has a few extra stuff, who cares? But then you can easily build self-contained binary wheels. So this will not build a portable binary wheel. If you do that, then you get a wheel that you need to install in the same Docker build, but it is self-contained, which means, for example, if you're building a MySQL client, you don't have to install the runtime version of the MySQL client library in the runtime image. Whatever parts in the runtime library will already be shoved into the wheel. This is amazing because it will make your runtime image so much simpler, and figuring out what is the right version of MySQL runtime for the MySQL dev is annoying. And MySQL is that's not a problem with MySQL, that's just a general problem. It's worse with other stuff. So this is already give you a lot of value. But if you want even better, you can have portable binary wheels. Portable binaries are one you can upload. So that tag, is specifically marked as a tag that, no packaging index will accept, right? It will get rejected in the upload phase. This is a feature, not a bug, because that tag is not safe to use in arbitrary images. If you want to build portable binary wheels, the first thing you kind of need to accept, right, is that you can't. But that's okay. Because you don't get to have to be perfectly portable. What you need to decide on is the portability level. What is the oldest thing I need to support? That's your portability line, right? So everything below that you don't care, everything above that you do care. So after you've accepted that you can't do perfect, this is what you can do, and that's great. So you figure out what is the oldest supported. And again, I can't tell you that because we already talked about how you need to choose a distribution and how you need to understand the LTS and how fast people upgrade to that. So I know what you chose, but you know what you chose, hopefully, and you know what people are using. Hopefully you can at least check or talk to them, worst case. And so you figure out which version they need support for, and that's the version you're going to build the portable binary wheel for. Once you've figured out all this stuff, which is not a technical issue, that's a social issue. You need to at some point actually talk to some human being. This is a good example of a many links tag. 227, I believe, corresponds to basically Debian versions after the thing that's before Buster. But I'm not going to trust my memory. It's a fairly new thing, but it's not super new. So probably that's a good approximation if you're building it right now. If you're watching this talk on a video, in the future, I hope this is a great future, and you probably want a different time. So how to generate binary wheels? I also can't tell you. That's because every single to misquote Anna Karenina, every Python, pure Python wheel is the same. Every binary wheel you have to build in its own way, right? There's usually documentation. Some documentation is good. Some documentation is so-so. Some documentation is an insult to humankind. That's the world we live in. I'm not going to sugarcoat it for you. Sometimes it does take a while to read the documentation, to understand what they're trying to do. But you try and try and try. Eventually, hopefully you succeed. Ideally, they have some unit tests that you can run to make sure that their build is correct. The nice thing is that after you have suffered, and like I'm not using this word lightly, sometimes it will be suffering, but after you have suffered, you can make sure that no one else suffers by encoding these build instructions in a Docker file, right? You build the dependencies, you build the PyPI, you upload it to like your native Python images, and that's done, right? They have a new version. First, depending on your religion, pray to whatever things you believe in. They have not changed how they build stuff. After you're done with prayer, you try building the new version. If you prayed well enough, you get to upload. If you not, enjoy reading the new version. Again, not the perfect world, but it's much, much better than 5 other teams trying to go through the same process, right? So it's actually like, it's better than the alternative, which is, it's not you. It's like 5 other teams who have gotten it wrong, and they come to you after it's broken in like subtle ways in production. So as horrible as this is, imagine the alternative. When you're trying to optimize layers, like I said, like you want to reduce the amount of copy minus form you want to do. Again, faster, usually smaller. That means you want to prep, right? You don't want to copy and then kind of move things around. You want to move things around and then copy. You also want to optimize the caching, right? Like Docker kind of build cache, or I really should say build kit cache, because that's actually how you build, right? Docker build is just like a very thin layer of UI, and barely even that on top of build kit. The build kit cache is amazing, but it's not going to be very amazing if you don't, give it the right stuff to work with. If you copy stuff that you need in the wheel that like is your specific application too early, then, and they say installing dependencies, build kit will be, oh, so that depends on the source files. I should probably do that again. That's going to be sad, because that is probably the slowest part of your build. Again, most people who use Python use it because they don't want to write C code. If you already wanted to write C code, you could have done it at the beginning. So probably your application does not have directly C code. So installing that is pretty fast. What you want to make sure is that the installing dependencies is cached, so you don't have to do it again, because that's hitting the web and then also like potentially compiling and doing a lot of stuff, not fun. So you need to know what invalidates caching. And basically like copy new files. So one trick I like is like, first you copy over the requirements files, then you install them, then like pip install -r, and then only then you copy the sources. Your requirements files probably are not going to change. Your source files probably change, because that is what the application engineers are actually debugging. Sure, occasionally you upgrade a version, but that doesn't happen again. And again, rebuild speed, right? This is what we're trying to optimize, rebuild speed, right? So you copy the requirements, you install the requirements, then you copy over the source files, then you build the wheels, then you install the files. It's going to get you a much, much better cached build. So you kind of communicate with build kit in a much better way. So I want to leave you with these thoughts. I don't think I like this phrasing anymore. Like it is kind of true, but I think instead of the word wrong, what I want to say is kind of okay or serviceable, right? It's really easy to, like pump out a Docker file that will kind of work, right? I've seen it happen a lot of times. It's much, much easier than to, kind of follow instructions I have laid over like almost 40 minutes now, right? It's much, much easier, right? Like I've told you what kind of thing you need to think about. All that thought takes time, right? All this like, kind of documenting, all that research into what other teams need and who we have and who's going to use it, that takes time. That takes a lot of work. But when you do all of the things I suggested, you get a much, much better thing. You get something that you can easily redeploy. You can easily intake hot fixes, right? When people are asking, like, how long does it take to deploy a security fix? When people are asking, how long does it take to debug? When people are asking, like, how long does it take to be more elastic? You have much better answers for them, right? You're in a much better place. You can get to amazing, right? So kind of, don't give up on, like, don't give up and do the obvious thing, right? Go the extra mile, spend some time, think before you Docker, right? Before you start, VI Docker file, before you, like, put the first byte, spend the, kind of day, 2, 3 days, you probably they're gonna be paid off. Think about it, right? Like, write the list of all the decisions you need to make, write the list of trade-offs you're gonna need to make. Do research, ask people, write some prototypes. That's gonna be work. but if you put in your work, you're going to get something pretty great. I think that's close to my time, and also pretty close to the end. So once again, thank you all for being here and listening to me chat about one of my favorite obsessions. Once again, thank you all, and thank you all for coming. I hope you enjoyed that.